So because you won't have a document for this, you're just going to have to listen and follow along, and we'll see how well you did. Where's my problem? Okay. So the problem, a dart with mass md is launched towards a block of mass mb that is suspended from a string of length L, as shown in the figure. The dart is moving horizontally with speed v immediately before it strikes the block and remains embedded. The dart block system then swings to a point at which a center of mass the center of mass reaches a maximum height h above the starting position, as shown at right above. The block's mass mb is greater than the dart mass md. And so there's not much calculation in this problem. It's just conceptual. This one's more conceptual. Indicate which object, the dart or the block, if either, experiences an impulse of larger magnitude during the collision. If the impulse is the same magnitude for both objects, state this explicitly and briefly explain your reasoning. Can anyone tell me whether they're the same or which one has bigger? It's the same. Good. How the points are awarded, there is 1 point awarded for part A. So this one, that's 15 points total. This one gets 1 point. 1 point is earned for a correct explanation in terms of force and time, using Newton's third law, or a correct explanation in terms of change in momentum, using conservation of momentum. It's essentially the impulse momentum theorem. Both objects feel the same force over the same time interval, so they must experience the same change in momentum. So example responses, both the dart and the block experience the same impulse because they exert equal and opposite forces on each other because of Newton's third law, and the forces are exerted for equal times. Right? That's the impulse approach. Or by conservation, and again, you don't have to explicitly state it like this, but you do have to have that in there. Like the point is earned for a correct explanation in terms of force and time. A point is earned for a correct explanation in terms of change in momentum. So you don't have to have it worded exactly like this, obviously. Okay, so the second one, by conservation of momentum, the decrease in the momentum of the dart, because the dart lost momentum, but by conservation of momentum, that means that the block must have gained momentum. So the decrease in the momentum of the dart must be equal and opposite to the increase in the momentum of the block, and therefore the impulse is the same in magnitude for both objects. So because both experience the same magnitude change in momentum, they must experience the same magnitude of impulse. Okay. Cool beans? Any questions about that one? So you either get 0 or 1 for that. 0 or 1 for part A. Part B, if the speed of the dart as it embeds itself into the block is greater than v, how would the maximum height reached by the center of mass of the dart block system compare to h? Explain your response without deriving or manipulating equations. So again, this is conceptual. Do you understand physically what's going on? So the answer is pretty obvious, right? If the block goes farther, what happens to h? Yeah, it goes up, right? Yeah. This one's 2 points. So if you want both points, you have to accurately include both of the following criteria. 1 point is earned for a statement that the final height is greater. So if that's all you said, then you get one of the 2 points. 1 point is earned for a statement of conservation of momentum to indicate that the final speed of the dart block system is greater, and an indication of conservation of energy leading to a greater height. So you have to say, well, it's an inelastic collision, momentum is conserved, so if the dart's moving faster, the block dart system is going to move faster afterwards. And if it's moving faster afterwards, then it has more kinetic energy, which means by the time it loses all the kinetic energy, it will have more potential energy, so it will be at a greater height. So you obviously don't need to word it like that, but you have to kind of get that. So an example response, because the momentum of the dart before the collision must be equal to the momentum of the dart block system after the collision, a higher dart speed, and hence higher dart momentum, will lead to a higher dart block speed after the collision, because the dart block is traveling faster after the collision. It has more kinetic energy, which means the dart block will swing higher. So if you said anything kind of like that, you get the second point. So 1 point for the correct answer, which is pretty obvious. Second point is for a real explanation involving both momentum conservation and energy conservation. Any questions? Comments? Concerns? All right. 2 students are discussing the motion of the dart block system at the instant it reaches a height h. The students make the following statements. Student 1 says the speed of the system at height h is 0 since it's moving in circular motion and centripetal acceleration is given by the acceleration is speed squared over r. The acceleration must also be 0. So let's talk about the parts that deal with student 1's reasoning first. That's parts C and D. Part C says which underlined phrase or phrases, if either, are correct about student 1's statement. If neither phrase is correct, write none. Notice it didn't say justify. So you didn't have to justify. You could just write the first one or the second one, and that's fine. So 1 point is earned for a correct statement and no incorrect statements. So that means if you said both are correct, you were right because one of them is correct, but you don't get the point because you have to have at least one incorrect, and you have to pick the one that's correct and then not pick the one that's incorrect. So student 1 is correct in saying that the speed at height h is 0. So his first statement, the speed of the system at height h is 0. Yes, it is 0 because it comes to a stop when it gets to maximum height and then it swings back down. So that is correct. Part D says which statement from student 1 is incorrect. 1 point is earned, same thing, for picking one incorrect statement and not the other one. So student 1 is incorrect in saying the acceleration is 0 at height h. The acceleration is not 0. And student 2 is right here. If the acceleration was 0 at height h, what would the block dart do after? What would it do if its acceleration was 0? It would stay. It wouldn't move. If its acceleration is 0, it stops. Right? An object at rest stays at rest unless you have an external net force, which necessarily causes an acceleration. So student 1 is incorrect in saying the acceleration is 0 at height h. All right. Now student 2 said these things. The acceleration of the system at height h can't be 0, or the system would not swing back down. That's true. The acceleration must be equal to g at height h, therefore. Okay. So which parts of those? So the student is correct in saying that the acceleration of the system at height h can't be 0 or the system would not swing back down. And that's what Joel pointed out. And you could literally write out the whole statement, or you could just say the first statement, and that's fine. You didn't have to. You don't want to waste time here. If you're doing an explanation or you're explaining an experimental design, yeah, you want to use complete sentences and stuff. But if it's like, which one's right, which one's not right, then just say the first one's right, the second one's not right. That's fine. Okay, so part F, though, student 2 is incorrect in saying that the acceleration is g at height h. And just so we all know why, in case you forget, just so we all know why. When the thing is at height h, I'm just going to make it look like that. The acceleration is not 0. The centripetal acceleration is 0 because it's not moving in a circle at that point. And centripetal acceleration is speed squared over r. If speed's 0, centripetal acceleration is 0. Okay? So the centripetal acceleration is 0. However, the acceleration is also not g because the acceleration is due to not just mg, but the tension force, right? And so I would have to decompose my tension force here, my mg, into these two, where this component of mg will balance the tension force, right? And this guy, if I measure this angle here, this guy, mg sine theta, that's the force causing the acceleration. So that force is equal to mass times acceleration. Everyone brought mass to the party. The acceleration is not g, it's g times the sine of the angle. The sine of the angle is always less than 1, so that tells you that it's not going to be accelerating as fast as it would be if it was in free fall. Right? If the acceleration was g, that means in the next instant it would be falling straight down. So the tension there is what's keeping that from happening and reducing the magnitude of the acceleration. So student 2, they're both wrong about what the value for the acceleration actually is, but they did have correct statements, at least conceptually. All right. The next one gives you an equation that you could, and you have actually done, if you've solved a ballistic pendulum problem. Or at least you could anyway, by applying both the conservation of momentum and the conservation of energy, mechanical energy. So this is part G, right? Yeah. The students correctly derived an equation for the maximum height. That equation is H equals 1 over 2G times mass dart times the velocity of the dart before it strikes the block, over the sum of the mass dart of the dart, the mass of the dart and the mass of the block, all squared. So this you can derive using conservation of momentum for an inelastic collision, and then conservation of mechanical energy as the block dart system moves from zero potential energy, maximum kinetic energy, to maximum potential energy and zero kinetic energy. Explain how this equation supports your claim in part B. So here you don't have to explain, notice how it supports. It already tells you what the equation is, and then asks you how this supports your conclusion from part B. And if you forgot, your conclusion from part B is the faster the dart goes, the higher the block system goes, right? So it's as simple as realizing that the height is proportional to the square of the speed of the dart before the collision. So if V increases, H increases, right? It's not linear. It's not linear, and that'll come into play in the next part. But everything else here is a constant on the right side. Right? Everything in this equation but H and V is constant. So the only thing that varies H is varying V, right? As long as we keep the same dart and the same block. And we're at the surface of the Earth. So how that might be worded, and this is a two-pointer. The response accurately includes both of the following criteria. 1 point is earned for a statement including functional dependence on the variables. That just means that H is a function of V, right? As V increases, H increases. Anything like that would get you that point. 1 point is earned for correctly asserting that as speed increases in the equation, H also increases. So they're essentially saying the same thing. If I was grading this and I had a statement that said something like, the equation shows that H is directly proportional to the square of the velocity, so if V goes up, H goes up. That gets both points. Right? It's not directly proportional to the speed of the dart, right? Because the speed of the dart gets squared. So you would get the functional dependence point for sure. I mean, you wouldn't technically be right, but there would be a little gray area there that the grader would probably have to go to their table leader to say, I think give this. I would probably give you a point if I was grading that on a test, and then make a comment saying, technically you're not right, but you do satisfy the criteria.
So it's just to the square of the velocity.
Yeah. So an example response, the equation matches my reasoning in part B. If the speed of the dart increases, the height of the swing increases because V is in the numerator. Okay. I don't like that one, but apparently if you said that, you'd be good. Now you do see right, everything in here gets squared, right? So it's proportional to the square of the velocity, which will be important in the next part. And I did have a question third period yesterday about this part. This is a linearization question. Right? We've done that a few times so far. We're going to do it a few more times. Chances are you're going to have to answer a linearization part, or there's going to be a linearization question on one of your FRQs on the actual AP exam. So the students performed several experimental trials. In each trial, a different speed is used, and the resulting maximum height reached by the center of mass of the dart block system is measured. Which quantities could the student graph to produce a straight line whose slope can be used to find the acceleration due to gravity? All right, so this is, as I said, a linearization question. Linearizing data means plotting it in just such a way that you get a straight line, and then you can set the slope of that straight line equal to a quantity in your equation, and then determine something in your equation. Okay? It's a very useful tool that takes things that are, say, inversely proportional or proportional to the square of something or proportional to the square root of something, because those are all curvy graphs, right? And so you can't really find a single slope on a curvy graph and get some information from that without some more sophisticated mathematics. But if you can just linearize it real quick, then you can have a slope, a constant slope, that will represent something in the equation. And the key is realizing what's varying first and what's constant. Okay, so I'm going to rewrite this equation, and the goal is to eventually rewrite it so I have something that looks like this. Right? Where x doesn't need to be a single variable. It could be a single variable to the third power. It could be the square root of a single variable, something like that. M doesn't need to be a single number. It could be a combination of numbers as long as they're constant, right? M is a constant if you have a straight line. So you want to get M, the slope, to be represented by a combination of constant values. And then y will just be the thing that varies when you vary what x is. So the things that are varying here are h and v. If I was to plot h versus v, what kind of equation do I get? Or what kind of graph do I get? If I graph this equation, this. What shape? What shape does the graph make? It's quadratic. It's a parabola, right? Right, if I graph these two, actually let me put it here. You get a parabola. Parabolas, I don't know if you know this, are not straight lines. So you can't get the slope of a parabola. You can do a curve fit and then do more sophisticated math but it's a little trickier. But what can I plot h versus so that I get a straight line? Anyone tell me? I could, if I could plot the square root of h versus something to get a straight line. But I think it's easier to just say, let me rewrite this actually. Let me rewrite this as h equals 1 over 2g times mass dart over mass dart plus mass block squared times v squared. When you're linearizing, you probably want to do that. It'll make it a little easier. Because if I note, yeah, there's a lot of junk here, but it's all constant, right? Everything that's not blue is constant. G is constant, mass dart, mass block, all constant. So this is my m in my y equals mx. H is my y. So what is my x then? V squared. Right, so that would be my x. This would be my y. So if I plot not h versus v, but h versus v squared, then I will get a line. Okay. And when I graph that and compute the slope, what does that slope equal? You don't have to read it all out, but you just say all that junk, right? This slope is equivalent to m, which is equivalent to all this. So say the slope just happened to be 4, right? When you did rise over run, you got 4. Well, 4 then equals 1 over 2g times md over md plus mb squared. Where g would be your only unknown. You would know the mass of the dart. In your experimental setup, you would know the mass of the dart, the mass of the block. You know the slope because you just computed it. So now you can figure out what g is. Okay. Obviously, we know what g is, but there are some experiments. There are some projects that engineers and scientists worked on where they collect a bunch of data and they're like, oh, I'm trying to get the permittivity of free space or some weird thing like that. And they graph their equations to force them into straight lines, compute the slopes, set the slope equal to what their equation tells them, and then compute what it is that they're looking for. Okay. So we're going to do this a few more times because I can almost guarantee you'll have to do it on the exam on one of your 5 FRQs. So hopefully as we do more of those And then I think what am I doing? I'm hoping. Why am I doing that? I'm hoping towards the end of the year we have plenty of time to review, depending on how fast we can get through our rotation unit, and we'll do quite a few of those linearization problems to get proficient with it. All right. So all that being said, let's see how it's scored. And notice what I could do also. I could plot, and I wouldn't do this because to me, I'm visual. I like seeing the h is by itself. It's proportional to v squared, so I just plot h versus v squared. But you could plot the square root of h versus v. It's the same thing, right? It's the same thing. You're just square rooting both sides there. Okay? So you can do that as well. I would just recommend doing it the other way. For me, it's much more straightforward. Take the thing that's already a single variable and plot it against the other thing, but with whatever exponents, whatever function, if it's sine or something like that. Sometimes you want to plot this versus the sine of that, you know. So, hopefully that helps with that. So, this is part G, right? No, part H. So this one's 3 points. And notice it did say, yeah. So 1 point is earned for plotting a variant of v on one axis. So that means you just say, I plot v or v squared or something on one axis. 1 point is earned for plotting a variant of h on the other axis. Those are whether you're right or not. You say plot h versus v. You get 2 of the 3 points there. Right? But then 1 point is earned for a correct power relationship between the two variables, i.e. h versus v squared, or the square root of h versus v. And you can plot v versus h, right? Or v squared versus h. You still get a straight line. It's just that would make my brain hurt trying to do it that way because h looks like it should be on the y-axis in the equation. But you could still do that. Okay. Yeah.
Okay, so for number h, I did it wrong. So what I did was I didn't know I had to use that equation, so I used the period of the pendulum equals whatever equals 2 pi over square root L over G. So I mean, I'm assuming I got the first 2 parts wrong. But I used that to solve for G because I didn't know how to find the equation. So would I still get part 3 right if the
Probably not, because you're using stuff that hasn't even been discussed yet.
Okay. That's what you did too. I didn't know we were supposed to use.
Okay.
So I'm like, what can I use to find G?
Well, it says in each trial a different speed v is used and the resulting maximum height reached by the center of mass of the dart block system is measured. So it's pretty much, you got to have the height in there somewhere. Yeah. Probably wouldn't get those points either. So you get a 0 for today. Sorry. You too, Carson. Okay. After the collision, the dart block system is then allowed to swing freely, and the students produce the graph shown below at left and labeled group 1 of the vertical position of the center of mass of the dart block system as a function of time. A second group of students makes a single change to the setup and then repeats the experiment. Their graph, labeled group 2 of the vertical position of the center of mass of the dart block system as a function of time, is shown at the right. Obviously, you have different stuff going on. And if you're in pre-cal or calculus, you know those are sine or cosine graphs. Technically, they'd be cosine graphs, right? Indicate the single difference in either the dart mass, initial dart speed, block mass, or string length between group 1 setup and group 2 setup that could lead to the difference between the two graphs. Notice it says indicate the single difference. There's literally any one of those things that theoretically will change will lead to the differences in those two graphs. Can anyone tell me what that is? The speed? It's the string length. Yeah. The speed is kind of counterintuitive, but remember, as long as we got small angles, it doesn't matter how fast it's moving, it doesn't matter the amplitude, how high it goes, as long as it's less than about 15 degrees, the period's going to be the same. And what these graphs are showing us is information, or at least it's giving us information that we can get the period for it. So if we look at, if we assume each tick mark is like 1 second, then it looks like the period for the group 1 is like 1.2 seconds. The period for group 2 looks like it's about 0.8, 0.9 seconds. So you have a shorter period. But what this is essentially a pendulum. And so you guys were talking about the pendulum equation. This is giving us information about the period of what is now technically a pendulum. And the equation for that is 2 pi times the square root of L over G. So the masses involved don't matter. The amplitude that's related to the speed isn't going to matter as long as it's less than than about 15 degrees. The only thing that dictates the period, which these graphs are indicate, is the length. And so group 2 has a smaller period. 2 pi tends to not change too much. G doesn't change. So if the period went down, then the length must have been shortened. Right? Shorten a pendulum. See right here. There's that period. That period. I shorten the pendulum length. Much smaller period. So what the scoring guidelines would say is 3 points. The response accurately includes all of the following criteria. 1 point is earned for recognizing that the period in the second graph is shorter. You wouldn't necessarily need to say the period. You could say the time for each swing or something like that, and the reader would know that that's what you mean. 1 point is earned for a statement about the dependence of the period on the length of the pendulum. 1 point is earned for indicating that the length of the pendulum must be shorter. Right. So you had to indicate indicate the thing, and that's the length, and then you had to indicate, then you had to justify that by saying, well, the period's shorter, therefore the pendulum length must be shorter. So an example response, since the period is shorter for group 2, and the period is related to length, if the period became shorter with no other changes, the length of the string must have been shortened. And that would get you all 3 points. So that's 15. Again, just add this up. This is for your own use, your own, gauging your own abilities. You don't need to submit your score like you did last time. This is just for you guys. And for the rest of the period, you can get started on the FRQ. That's on AP Classroom now, the second one. Yes, sir.
So for I didn't put that the period was shorter in group 2, so that the string was shorter. I just said that the period for the pendulum equation is only affected by length and gravity. Gravity can't change, so you know that. So I only get that 1 point.
I feel like you would get at least. Because you recognize that the period was shorter, right?
I didn't say that.
You didn't say that? You did say that the period is dependent on the length, though, right? Did you say that the length was shorter?
No.
Yeah, you probably only get 1 point there. Yeah. Try to be as descriptive as possible. I would probably give you 2 out of 3 because I'm a little more lenient than the College Board will be, but that's because we haven't gotten to the end and you're not experts yet, which you will be in a month or 2. Speaking of the AP exam, William, you still have to pay for part of it. At least that's what my records indicate. I can send you the link too. You can do it online.
So, Mr. Graham, for the
Would you want me to do that
Yeah.
on Remind?
Yeah.
Okay.
Thank you. For the FRQ, submitting it into AP Classroom, how do we do that?
I think you got to take a picture.
You can take a.
Can you take a picture with your Chromebooks?
Yeah.
Have you? I mean, have you done? Have you?
I've done that once. I don't know if you can, but I've not done that once.
How have you done it in any of your other AP classes? How do you submit FRQs in other AP
I use
classes?
mine. Well, I haven't done an FRQ in any of my other classes.
Oh, really?
What we do for Mr. Kelly's class, which is my only other science class, or AP science class,
How's he do it?
is, well, we do it, and there's like a 50-minute time limit, or 45-minute time limit, and then we write it all down, and then we just use our phones, and we take pictures, and we submit it to Canvas. But he doesn't use AP Classroom, he uses Canvas for everything.
Okay. Then we might have to do it that way.
I know, because last year when I went for like AP Stats, you would take the picture on your phone and just upload it to Google Drive, and then when you go into attach a file on AP Classroom, it's in the Google Drive.
Okay, there you go.
How?
How long does that? So I should budget time in for that then, obviously.
Oh, is he talking about uploading my picture?
Taking a picture with your phone.
Uploading it to my Google Drive.
Yeah.
That's what I did for my AP test for lab last year.
Okay.
My only worry is just like, it'll sometimes take a very long time, and sometimes it takes really no time at all.
Like to get it uploaded.
I know you can go into AP Classroom on your phone and take pictures.
You can?
Yeah, I think
While you're in AP Classroom on your computer?
Wait, you can, so if I logged into AP Classroom on my phone,
you should be able to.
and I could be on this at the same time,
Yeah,
but like if I submit it, will it pop up on my screen?
I'm not sure. I think you might have to submit it to your phone.
Okay.
Yeah, give that a shot.
I don't know how
Hey.
that works with the lockdown,
Oh yeah. Oh yeah, that wouldn't work with the lockdown browser. What a nightmare all this is.
No.
Stupid COVID.
Canvas was working fine.
Is that okay?
Yeah.
You guys will still be okay with that? Alright. We'll probably do that then. Pain in the butt. COVID. Although without COVID, I don't know. We might still have units 8, 9, and 10. So that might have been the impetus to getting rid of those units. It's really silly though. Those 3 units are covered in AP Physics 2 and AP Physics C. So it's like, do you really need to do them in AP Physics 1? It doesn't really make sense. I sent you the link, William. I'll add a page to the module for today to upload your FRQs if you can't get it on AP Classroom. So you can do either or. There's a page on Canvas now.